बिनंदा दे हनीवेल बिनंदा दे।
कंग्रेचुलेसन माय हनीवेल टीम। आज मैं बात करूंगा जैसे बीएमएस कोर्स के बारे में हमजा जी ने कुछ जानकारी दिया है। तो जैसे मेरा सभी जो वीडियो है इंग्लिश में नहीं है तो उन्होंने इंग्लिश में जानकारी आपको देगा। तो आज मैं बात करूंगा इंग्लिश में, लेकिन आपको ये हिंदी टाइप का सुनने को मिलेगा क्योंकि मुझे भी सुन रहा हूँ मैं भी, तो पता चल जा रहा कि ये हिंदी वाला आदमी है और इंग्लिश में बक रहा है। तो कोई बात नहीं, उसमें कोई दिक्कत नहीं, बस आपको समझ आना चाहिए, ठीक है। तो चलिए पूरा शुरू करते हैं। चैनल को सब्सक्राइब के साथ नोटिफिकेशन ऑन कर लीजिए। हेलो एवरीवन, वेलकम टू डीके बीएमएस इलेक्ट्रिकल। टुडे आई विल टॉक अबाउट बीएमएस कोर्स एज यू वुड नो which is the tech system. Hamzaji has given information about BMS course. He will teach BMS course. You will get to learn a lot of information about BMS. So whenever you want to become operator or technician of building management system or want to read about BMS, then definitely join Mr. Hamzaji course. Here you will not have to pay much money. You will get to learn BMS in less than 1000 rupees. This entire system will remain online. You can do the online course here. He made many videos about BMS. If you want to learn more than 100 BMS, then take online course. Shriman Hamzaji, I think the commissioning engineer will be there. He has a lot of knowledge of BMS and has worked in Honeywell. If you see his video, it is of very high quality and completely information about automation is giving. So let's talk fast. How can you take Hamzaji course? Then his channel name is, if you go to Tech System, their full links is posted on the community tab, and if you check mine in the description, I have shared their link. If you want to, you can also join from here, and he has explained the course of BMS system in a proper way. Complete what you will get to see in the video now. Then you can also see what explanation. Must watch that video about how we'll tell the whole. तो लिंक में जाएंगे तो सबसे पहले इस तरह का इंटरफेस आपको देखने को मिलेगा। पहले 799 था, आप 649 रुपया कर दिया, लेकिन आपको उस चैनल में जाके सब्सक्राइब करना होगा तभी आपको ये फैसिलिटी मिलेगा। और बाकी का जानकारी उन्होंने खुद दिया है। तो चलिए फिर ओपन करके पूरा उनका जानकारी सुन लेते हैं।
In this course, you will learn everything you need to know about BMS to start or enhance your career in the BMS field. My name is Abdurrahman Zafar and I am thrilled to be your instructor for this course. With years of experience working in the building management industry, I have gained a wealth of knowledge and expertise that I am excited to share with you. After taking this course, you will be able to completely understand the core concepts of BMS, and it will provide you a boost to start or enhance your career in BMS design, programming, installation, and testing and commissioning. By end of this course, you will also understand about working of different BMS components including sensors, controllers, and actuators. You will also be able to read and understand important BMS documents, understand IT networking concepts, and BMS communication protocols like Modbus and BACnet. Either you are an electrical or mechanical engineer, consultant, facility manager, or a technician, this course will equip you with the knowledge and skills needed to succeed in the BMS industry. We will start with fundamentals of electricity and control systems. Then we will discuss in details about functionality of field devices. Then we will learn about DDC controllers and IO modules. Then we will discuss about HVAC systems in details. After that, we will talk about IT networking concepts for BMS. Then we will learn about BACnet and Modbus. And in the last, we will talk about testing and commissioning and graphic workstation for BMS. With 7 hours of video content, quizzes, and downloadable resources, you will find this the most comprehensive BMS course on Udemy. Also, unlike other courses, you will find detailed discussion about operation of HVAC systems and how to control and monitor them from BMS. So if you are ready to start your journey into the world of BMS, enroll in this course today and let's get started. Hello everyone, welcome to BMS Fundamentals course. This is an introduction video to the BMS. In this video, you will learn what is BMS, what are components of BMS, what are features and benefits of using BMS. So let's start with what is a BMS. BMS stands for Building Management System. It is also known as Building Automation System or BAS. A commercial building consists of many mechanical, HVAC, electrical, security and life safety equipment. A proper control, monitoring and coordination of all these systems is required to have a productive, safe and comfortable building. For example, in summer when cooling demand increases, more chillers shall be turned on to meet that requirement. So in such scenarios, BMS shall be doing this coordination and control of the chillers to meet that requirement. Also in many other scenarios, a proper control and coordination and monitoring is required, which is done by the BMS. So we can define BMS as an intelligent microprocessor based system which centralizes and simplifies the control, monitoring and operation and management of HVAC and other building systems to have safe and comfortable working environment with energy savings and efficient operations at reduced time and cost. BMS achieves safe and comfortable working environment by the control of HVAC equipment like air handling units, chillers, fan coil units, boilers, pumps, VAV boxes and many other systems. Apart from HVAC, other building systems can also be integrated with BMS like CCTV, security, fire alarm, elevator, energy management, lighting and other systems can also be integrated to BMS to have an integrated building with all things on a one workstation and proper coordination between all the systems. Now let's talk about components of BMS. In terms of hardware, BMS consists of three different levels. First level is a field level which consists of input and output devices. Input devices can be sensors like temperature sensor, humidity sensor, carbon dioxide or carbon monoxide sensor, and contact closure devices are switches which can be differential pressure switches or water flow switches, and output devices can be actuators like damper actuators or valve actuators. Then we have automation level which consists of microprocessor based DDC controllers. These DDC controllers are connected to the input and output devices. DDC controllers take input from the input devices, process that input using the programmed control logic, and then control the output devices accordingly. Then we have an automation level which consists of a BMS workstation. This is also known as GUI or graphical user interface. BMS workstation consists of graphics, trends, alarms and reports. In next video we will talk about the BMS architecture in more details. Now let's have a look at features of BMS. First of all, BMS consists of a graphical user interface which presents the data in a user-friendly manner from where operator can monitor and control all the connected equipment to the BMS. Alarm management is one of the most important features of BMS. Alarm management console presents different alarms in sequence of importance and time. Different priorities can be configured for different alarms. Most critical alarms will be shown on the top of the list. Different instructions can also be set which will guide the operator to take appropriate actions for different alarms. Alarms can also be notified using SMS and email notifications. Trending is an automatic gathering and storage of historical data from field equipment. It helps in troubleshooting and later analysis. BMS also prevents unauthorized access to the system using password protection. Also, we can define different roles for different operators to limit their access, meaning operator will be able to only access specific area and functions for which he is authorized. Operator log summary is also available in the BMS, which we can be referred later on to know which actions were taken by the which operator. Time scheduling means we can schedule the start and stop of different equipment. This is mostly effective for lighting and occupancy control. It also helps in saving energy and helps in efficient operations. BMS also provides remote connectivity to the system so that we can access the system using local area network, or also we can access the complete system over the internet. Now let's have a look at benefits of BMS. BMS provides comfortable living and working environment through better temperature and humidity control, and also good air quality through proper ventilation throughout the building. Second benefit of BMS is a faster response to the occupant needs and user complaints, and also faster response to the trouble conditions. Third benefit is maintenance saving. As efficient control gives less wear and strain to the equipment, it also increases the life of the equipment. Runtime monitoring of the equipment also alerts timely maintenance, which avoids expensive failures. Through efficient controls, BMS helps to eliminate unnecessary system operations, which results in energy savings. BMS also helps to take steps to reduce system energy consumption like optimum start, night purge, and time scheduling. BMS also provides valuable real-time data from the field. This data can be presented in the form of reports, charts, or graphs. Critical reports can also be sent via email or SMS. So that's all for this video. In next video, we will discuss about BMS architecture. In this video, we will talk about Contactor. Contactor is an electrical switching device which is used to turn on and off an electrical power circuit. Here is a symbolic representation of a contactor. It works on the same principle as a relay. It have a coil where a control voltage is applied, and then it have switching contacts. When contactor is energized, it pulls the movable contact, and which closes the contacts, and connected load is turned on. Contactors are used to power up and control lighting circuits inside large and commercial buildings. They are also used to control electric heaters inside air handling units and FCUs, and they are also part of the starter circuits for the motors. Here is how to wire a contactor to control switching of an electric motor. Here, three-phase power supply is applied on one side of the contactor, while the other side is connected to the motor. This is direct online starting method for the motor and is usually used for motors with ratings up to 7.5 kW. For larger motors, star-delta starting circuit is used, which is explained in details in an upcoming section. So when a control voltage is applied on the contactor coil, magnetic field generated inside the contactor closes the contact points, and the power is now applied on the motor and motor is turned on. This control voltage to energize the contactor is supplied by a DDC controller, or it would be supplied by a selector switch inside the MCC panel. As we saw that working principle of both relays and contactors are same, but both have different applications. Relays are used for switching of low current applications like dampers and valve actuators. Contactors are used for high current load applications like fan motors, elevator motors, and pump motors. Contactor shown here is a 4-pole contactor where we can connect three-phase line voltages along with the neutral. Power supply line voltage is applied on the upper terminals and the load is connected on the down terminals. Control voltage is applied on the A1 and A2 terminals, same like a relay. Control voltage can be either DC or AC depending on the rating of the contactor. You can find the rated control voltage on the contactor nameplate or in the datasheet of the contactor. Apart from the coil and switch contact points, contactors also have auxiliary switches which provides feedback about the latching status of the contactor. Here we have two auxiliary feedback contacts, NO and NC contacts, same like we saw earlier in the relays. When contactor is energized, NO auxiliary contact is latched and provide feedback signal which can be connected to the DDC panel and can be monitored at the BMS workstation. Now let's have a brief look at duty rating of contactors. Contactors have different duty ratings like AC1, AC2, AC3 and AC4 and so on, but we will discuss here only AC1 and AC3 ratings, which are more commonly used in our BMS applications. AC1 are general purpose contactors which are used for non-inductive or slightly inductive loads, for example electric heaters. These loads shall have power factor between 0.95 to 1. AC3 contactors are used for switching of squirrel cage motors as they draw high inrush current during starting, which is up to 5 to 6 times more than the nominal current of the motor. AC3 contactors are designed to withstand that high inrush current. They are used for motors for fans, elevators and pumps. So inside the MCC panels of your air handling units, you will find these AC3 rated contactors. This is duct temperature and humidity transmitter from Honeywell. The part number is H7015B1060. Since it is a transmitter, so it provides a 0 to 10 volt signal for humidity, and also for the temperature, we need a 0 to 10 volt signal. And we also need a power supply. We can use 24 volt DC or 24 volt AC power supply for this transmitter. This is the probe which goes inside the duct. This is mounting flange. Okay, here we have an arrow showing the direction of the airflow. So we install this mounting flange of the duct, and then we insert this humidity sensors inside this duct. So there is a screw here to loose. So like this, we can insert this humidity sensor inside the duct. And then regarding the connections, here we have number 1 and 2, we need 24 volt DC or AC power supply. On number 3, we will get a 0 to 10 volt signal for humidity. And on number 4, we will get a 0 to 10 volt signal for the temperature. So this is a air temperature and humidity sensor for installation inside ducts. This is air filter, and from here it is sensing our temperature and humidity. This is the sensing element, our temperature sensor and humidity sensor installed here. So when air will pass through this sensor, it will detect the temperature and humidity value of the sensor. This air filter is replaceable, or after some time if it is clogged or there is any problem, it can be replaced. This is an immersion temperature sensor which is installed inside the pipes to measure temperature of the chilled or hot water. The part number is VF21B54 from Honeywell. Here this is our immersion well which is installed directly inside the pipe using these screws, and then after that this temperature sensor is directly inserted to this immersion well like this. Okay, and here since it's a thermistor and it's NTC 20K, we have only two connections and we need a 2-core cable for making a connection here. It is a passive sensor, we don't need any power supply for this one since it's a thermistor. In this video we will learn about different types of points used in BMS. BMS points can be categorized into two main types, which are IO or physical points, and other type is software points. IO points are input and output points which are used to control and monitor the building equipment, while software points are the logical points which are only used inside the software. They are not controlling and monitoring any hardware or any equipment. Example of a software point is a temperature set point. This temperature set point is created inside the software to control the cooling or heating of an AHU or FCU or VAV. So this temperature set point can be changed by the BMS operator from the workstation as per cooling or heating requirements from the occupants. Another example of a software point is an alarm point. These type of points are created inside the software for indication of alarms. For example, a fan failure alarm can be generated if belt of your AHU fan is broken. Now we will discuss about IO points in more details. IO points can be digital and analog. Digital points have only two states which are on and off. You can think of digital points like a switch which you use to turn on and off the lights in your home. The lights can be either on or off. Similarly, digital points also have only two states. You can think of them as 0 and 1 or on and off. While analog points represents continuous signals like a 0 to 10 volt DC signal is an example of an analog value. This point can have any value between the defined range. So digital is a point which has only two states, and while analog is a point which can have continuous values between a defined range. Digital and analog points are further subdivided into different types. First of all, we have digital inputs and digital outputs. Then we have analog inputs and analog outputs. We will discuss about each type in further detail. Let's discuss about digital inputs. Digital input points have only two states which can be either on or off. These points are used for monitoring the status of equipment. Examples of digital input points can be fan run status, fan trip status, status from a differential pressure switch, status of a pump. These are all examples of digital input points, which only represents that either this equipment is on or it is off. Then we have digital output point. It also have two states and it is used to give command to the equipment like on command and off command. Examples of digital outputs are fan run command, pump run command, open command for a digital damper actuator. So digital outputs are used to control the equipment and field devices, and they can control only two states. They can either turn it on or they can make it off. Analog input is a continuous signal which represents some other quantity. Analog inputs are used to monitor the values from sensors like temperature sensors, pressure sensors, or they can be used to get the feedback from the field devices like valve actuators and damper actuators. Analog input can be a 0 to 10 volt DC signal, or it can be a 4 to 20 milliampere current signal, or it can also be a resistive signal from a thermistor. Let's understand an analog signal with an example. A water pressure transmitter measures the value of pressure and converts this pressure value into a 0 to 10 volt signal. DDC reads this electrical signal and converts it again to the pressure value using already defined criteria inside the DDC. If this pressure sensor measuring range is 0 to 6 bar, then 0 pressure will be represented by 0 volts, and when pressure is 6 bar, then the transmitter will send 10 volt DC signal to the DDC controller. The same configuration will be done inside the DDC controller during the programming. So the DDC controller will know that what is the pressure value based on the electrical signal it receives. For example, if DDC controller receives a value of 5 volt DC, then it will know that the pressure value is 3 bar. So in this way, the pressure transmitter converts pressure into the electrical signal, and once it reaches to the DDC translates it back to the pressure value based on the configuration done inside the DDC controller. Other examples of analog inputs can be temperature sensors. This temperature sensor can be a thermistor, which will give a resistance value to the DDC based on the temperature. This resistance value will be changing as per change in the temperature. So this is also an example of analog input because this is not fixed and it does not have only two states. Another example is modulating damper actuator feedback. This feedback value can be 0 to 10 volt DC. So if the actuator is fully closed, it will give 0 value to the DDC controller, and if it is fully open, it will give 10 volt DC to the DDC controller. And if it is half open, it will give 50% value to the DDC controller. Similarly, the valve actuator feedback is also an example of analog input. Analog output is a continuous signal which is used to control the modulating actuators. 0 to 10 volt DC signal used to control a modulating valve actuator is an example of analog output. Here is an example where DDC controller use a 0 to 10 volts DC analog output signal to control the opening and closing position of a valve actuator. If we want to fully open this valve actuator, the DDC will send 10 volt DC signal, and if it wants it to open partially like 70%, then 7 volt DC signal will be sent to this valve actuator. And in response to this signal, the valve actuator will open or close. So in this way, we can control the valve actuator to open or close to different positions using an analog output. Remember the difference between digital output and analog output. Digital output can have only two states. It can either open or close or turn on and off. While using analog output, we can control the positions very precisely. In this video, we will discuss about different types of I/O modules used in BMS. In previous videos, we learned about different types of I/O points. Also, we saw that some DDC controllers have built-in I/O points, while other DDC controllers don't have any built-in I/O points. Usually, we require a lot of points to be connected to a DDC controller inside the DDC panel. So, expansion I/O modules are used along with the DDC controllers. Here is an example of a DDC panel from one of our projects. This is a DDC controller which don't have any I/O points. So, we have used expansion I/O modules which are connected to this DDC controller using a communication bus. You can see that all these modules are connected in series, and then they are connected to the DDC controller, and they are communicating to the DDC controller using a communication protocol. Every manufacturer uses different communication protocols. The one which is used here is LON. Usually Honeywell now they are using panel bus communication protocol for communication between the DDC controller and the expansion I/O modules. Some other vendors use open protocols like BACnet MSTP and Modbus. There are different types of expansion I/O modules, which are DI modules. DI means digital input modules. Then we have DO or digital output modules, analog input modules, analog output modules, and then there can also be mixed I/O modules. In mixed I/O modules, all different types of I/Os are mixed together. Every manufacturer have different types of I/O modules with different model numbers and characteristics. Every manufacturer have their own I/O modules with different part numbers. We will go through panel bus I/O modules which are used by the Honeywell. We will go through the manual of these I/O modules to see the details about them. In this video, we will learn to read drawing of an MCC panel. Also, we will see that how we can make connections of BMS points inside the MCC panel. This MCC panel drawing is for control of an AHU fan using a VFD and a bypass star delta circuit. The primary starter circuit is the VFD, while we also have a star delta circuit for standby in case there is a failure on the VFD, so that we can run the fan using the bypass star delta circuit. This is the outer view of the panel with dimensions and size of the panel. As you can see here, we have selector switches, and also we have indication lamps on the front of the panel. First of all, we have auto, off and hand switch. Using this switch, you can select to run this fan in the auto mode or in the hand mode. To run it from the BMS, this selector switch shall be in auto mode, or if you want to run it manually from the MCC panel, you shall make this selector switch in the hand mode. Then we have an additional selector switch to select between the VFD and the bypass starter circuit. In normal mode, we will run this AHU in the VFD mode, but if there is any failure on the VFD, we can run this fan in the bypass mode. Then these are the indication lamps that is fan running in the VFD mode or bypass mode, is motor on, or if there is any fault on the VFD or motor strip, or if there is any fire alarm signal, there is an indication provided here. Then here we have a filter for proper ventilation inside this MCC panel, because there is a VFD inside this, and due to which heat will be generated inside the MCC panel. So it is necessary to have a forced ventilation. If you are in the operation and maintenance team, you shall properly clean this filter and ensure that the fan is running properly to avoid failure of the VFD components. This is the inside view of the MCC panel. Here we have power terminals. Then here are the control terminals to terminate our BMS cables. This is the VFD. Here we have MCB. Okay, these are the trunks for internal wiring of the MCC panel. Here then we have the contactors, overload, timer. Then these are fuse, and these are the relays. And here we have additional trunking. The panel size is also mentioned here. So these are the legends. So from here you can see that VFD, VC is VFD output contactor. So we will go into details about that. This is the power circuit of the VFD. Here we have incoming power. Okay. Here, this is the power circuit of the VFD. Here we have the incoming power to the MCC panel. Then this is our Danfoss VFD. This is the bypass circuit. Okay. This is the star delta contactor. These are star delta contactors. These three contactors are for star delta. And these two contactors are used to select either the VFD or the bypass mode. So this is the VFD output contactor, and this is the bypass contactor with overload. Here we have the control wiring diagram of the MCC panel. So first of all, we will see that how we can make connections for the BMS control signals. First of all, here we have the FACP. This is a fire alarm interlock signal, which shall be terminated on terminal number 14 and 15. This signal shall be normally closed. So in case of fire alarm, this contact will be opened and the MCC panel will shut down the AHU. Then here we have AHU motor run command from the DDC. This command signal shall be terminated on 16 and 17 number terminal. Here we have terminals for the RS485. These terminals will be used for integration of the VFD to the BMS using Modbus or BACnet MSTP. Then we have terminals for speed control and speed feedback. This terminal 20 and 21 will be used to control the speed of the VFD, and then we will get the feedback on terminal number 18 and 19. Here we have the monitoring terminals where we shall connect our cables for the BMS. First of all, we have the status of the selector switch, which is the auto status. It shall be terminated on terminal number 27 and 28, and then the hand mode status is available on 29 and 30. Similarly, we have other signals available, like motor run status is available on terminal number 35 and 36. In this way, by reading the MCC drawing, you can know that where you shall terminate your BMS cables. In this video, we will discuss that how we can connect our BMS controllers to the IT network and what are the requirements for this. For this, let's take an example of a building where we have multiple DDC controllers at different locations and a BMS workstation. Now we want to connect all these controllers and workstation to a network so they can communicate with each other and we can control and monitor equipment from this BMS workstation. Here we have multiple options. First option is to make a dedicated physical LAN for the BMS. For this option, we have to purchase network switches, install them at feasible location, and then pull network cables from our DDC controllers to these switches to connect. For our particular case, we may bring two switches and place them at first floor and connect all our controllers to these switches. And also we can connect these switches together. This option to make a dedicated physical LAN is suitable only if we have a small building with a few number of controllers. But if you have a large building and you have many number of controllers distributed across the building, then it is not a feasible option. For that case, we shall go to the second most suitable option, which is using the existing IT infrastructure of the client to connect our BMS controllers. For this option, we have to coordinate with the network administrator from the IT team of the client. You shall request them to provide you a separate VLAN for the BMS. For this, you shall prepare a layout or a list of your controllers with the locations and request the network administrator to show you the locations of the nearby network switches so that now you can pull your network cables from the DDC controllers to those switches. After connection of the network cables on the switches and the controller side, the IT team will configure a VLAN for the BMS and they will provide you the subnet range of the IP addresses. You can assign these IP addresses to your controllers and now the BMS network is ready. So this second part of using the VLAN is the most suitable because in this case you don't need to install any network switches and you don't need to manage those switches. You will be using the existing IT infrastructure of the building, and just you need to request the network administrator to prepare a VLAN for you and to provide you the IP addresses of that VLAN. I hope these videos will help you to better understand about networks, IP addresses, subnetting, and what considerations are needed to set up a BMS
वीडियो
network.
देखने के लिए बहुत बहुत धन्यवाद और जाके कोर्स को अप्लाई कर लीजिए। ये कोर्स ज़रूर अप्लाई कर लीजिए। धन्यवाद।